everybody. Welcome to your third lecture. This lecture is going to be on atoms, elements, and compounds. This is also going to be on, I believe, types of bonds, but we'll see depending on the length of this lecture. So our aim for today is to describe all the components, that should be an S, of matter. So we're going to begin with what is chemistry. And chemistry is the actual study of matter. And matter, by definition, is anything that takes up space or has mass. So everything in the universe is made up of matter, and matter is composed of these things called atoms. Again, mass, for those who didn't know, by definition, is the amount of matter that an object has. So we're going to start with atoms. They're the smallest or simplest particle of an element that still has all the properties of that element. So what does that mean? So let's think of gold. All the little gold atoms have the same properties. So I'm not going to see a silver within that gold atom. Do you understand that? So atoms are extremely small. We can actually see them with this cool microscope. And yeah. So the parts of an atom, there are three subatomic particles: protons, neutrons, and electrons. So in the nucleus, in that center part of the atom, there are two types of protons, which are positively charged, and two neutrons, which have no charge. And the nucleus, that's where all the mass of an atom is contained. And so, just fun fact, all atoms of a given element has the same number of protons. And then our last subatomic particle is electrons, and they're negatively charged particles. And the electrons, they're on the outside of the nucleus, and these things called energy levels or electron clouds. So elements. Elements are pure substance that cannot be broken down into a simpler kind of matter. So what does that mean? Let's say we have an element, right? An element is composed of these atoms. Let me find my screen. Where am I? Okay. So composed of its atoms, we'll make them little circles. This is our element. So if I took this section, it's still the same type of element. So this element will have the same properties as this. Okay? And what they're saying is that it cannot be broken down into something different. So even if I took this little atom, still all of these have the same properties. Okay, so it doesn't matter how small I break down an element, the properties do not change. So again, all elements are made up of one type of atom. So there's this thing called the periodic table of elements, and it has all the naturally occurring elements that can be found in the world. So again, 92 are naturally occurring, and it actually has 118. So 90% of all organisms are composed of four main elements: oxygen, carbon, hydrogen, and nitrogen. And on the periodic table, again, all elements will have a unique chemical symbol. It has one or two letters. The first is always capitalized, and some examples are oxygen O, carbon C, fluorine F, aluminum Al, so on and so on. So here's the structure of an atom. Again, in the center you have your protons and neutrons, and the outer you have your electrons. So this is where you talk about the clouds. Like, they're not designated these little circles, they're kind of like in a clouds section. Oh yes, I forgot to mention. So the properties of an element is defined by the electrons. Remember properties. So going more into neutrons. So all elements will have the same number of protons but different number of neutrons. So when they have different numbers of neutrons, it's called an isotope. So this carbon right here has 6 neutrons, 7 neutrons, 8 neutrons. And when you change the number of neutrons, you change the mass of that element. So changing the number of neutrons doesn't change the overall charge of an atom because, again, neutrons have no charge, but it can give off this radiation, and it's this type of radiation makes that element known as a radioactive isotope. This is how we get X-rays. So now we're going to go into the periodic table of elements. So the periodic table, so the way it's arranged is pretty cool. So if you go down, across, they're known as periods, and that means it tells us the energy level. And then the families, it's the outer shell. So what does that mean? So okay, the energy level is just the number of shells. So this has 1 energy level, 2, 3, and 4. So these are fam. Okay, do you understand that? We don't really need to know that much about the periodic table, so I'm not going to go into it. For those in my chem class, we absolutely will. Okay, now we're going to go into compounds. So compounds are pure substance formed by 2 or more different elements combined. So example would be water, H2O, carbon dioxide, and this C6H12 you will see a lot. It's called glucose, and it's just, the formal way of writing sugar. Compounds, they always exist in a particular ratio. So what does that mean? So there will be always twice as many hydrogen as oxygen. So this will be a bad example because this never exists, but let's say this glucose molecule, you can see C3H4O3. So, and then compounds, they cannot be broken down into simpler compounds or elements by physical means. So what does that mean is that the properties do not change. So if I have this this H2O, I can't break it down any further and still retain the properties of that element. So because if I break it down, then I'm left with 2 hydrogens and an oxygen, and they won't have the same properties as a water molecule. They're going to have completely different properties. So elements, they can undergo chemical reaction to combine with other elements in order to be stable. And what we define as stable is when its outermost shell has 8 electrons. That's the goal for electrons. That's #life goals. So now this brings us into chemical bonds. So a chemical bond is just the force that holds atoms. Remember, atoms, not compounds, atoms together. And the electrons are directly involved in the formation of the bonds. So a little background knowledge. They travel around the nucleus in their quote-unquote energy levels, and each energy level has a particular number of electrons. So the first energy level has 2, the second one has 8. So our first type of bond is called a covalent bond, and it's formed when an atom shares 1 or more electrons. So covalent bonds can actually only occur between non-polar elements. Non-polar. So a molecule is just a compound in which the atoms are held together by covalent bonds. So, okay, a molecule can only be a molecule can only have non-polar elements. So carbon, hydrogen, oxygen, boron, nitrogen. Those are some non-polar elements that can be in a molecule. So covalent bonds can have single and double and triple bond depending on the amount of shared electrons. So there are actually two types of covalent bonds, nonpolar and polar. So nonpolar is just equal sharing of electrons, and polar is unequal sharing of electrons. So this CH4 is an example of a nonpolar because all the electrons are being kind of like evenly pulled because these four hydrogens. Just think of it as being balanced. So this whole molecule is kind of being balanced because, they're pulling evenly at the sides. But this water molecule is nonpolar because think about it, it's unequal pulling. So this side is being pulled more, and there's like nothing here to balance it out. If you're in my chemistry class, we'll talk about electronegativity. So our second type of bonding is called ionic bonding. This is when the electrons are being pulled so much that it actually just gives it away. It's like you want it so much that you could just have it. And so this creates a charge on an element, and any element with a charge is called an ion. So let's look at this, sodium and calcium. So ionic bonds occur between nonpolar and metal elements. So this chloride ion is your nonpolar, and the sodium Na is your metal. So this last electron, there's an electron over here, was pulled so much by this chlorine that it just took it and transferred. And it's easier because it takes less energy just to give that electron than for this sodium ion to take all 7 of these outer electrons. And again, the goal for electrons is to have its outermost shell filled. So now this is its new outer shell is filled, and here's his outer shell, and it's now filled. So by giving that electron, it created a positive charge, and now this has one more electron than it would normally have, now has a negative charge. So remember, electrons are negative, so it has more negative. And these forces are held together by something called electrostatic forces, and it's just what that means is just that there's a positive and negative, and they're attracted to each other. That's it. Again, here is a picture. Again, the electron was given to chlorine, and this is its ionic bond. They're just held together by electrostatic forces, so Na and Cl. So generally metals will donate electrons, and nonpolars will accept the electrons. So again, the metals will give it away, and the nonpolars will take it away. And our last force is just van der Waals forces. We're going to get into van der Waals forces more when we get into hydrogen bonding, but that won't be until 2 sections later. So what are van der Waals forces? Van der Waals forces, it just mean that, so let's say we have our covalent bonds. Let's go back to our covalent bonds. So this molecule over here, carbon with these 4 hydrogen or 4 H's. So even though they're sharing it evenly, there's you can never share something completely even if it's the same molecule. There's at some point one will pull the electrons closer than the other, and it's going to create these slightly negative and slightly positive charges. So this carbon over here, oopsies, let me go back to this carbon. So this carbon is going to be slightly negative and slightly positive, right? And again, these electrostatic forces are going to be a positive and negative. So what van der Waals forces are is generally occurs between molecules. So let's say I have like a carbon here. Boop, 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 boop. Right? It's going to occur between these molecules, and that's how they're going to be held together. And the van der Waals forces are extremely important in biological processes because we'll get into that. But again, it's just defined as the attraction between molecules. So again, only nonpolar. Okay, end of lecture. Have a good night.